Hello everyone, how are you? In this video, I am going to guide you everything about DQ and how to use it in Python. Basically, DQ is doubly ended queue. It means in this queue, you can add an element at the start as well as at the end, and you can remove the element at the start and at the end all in constant time. This DQ is a very important object, or I would say a very important data structure if you want to master and solve data structure and algorithm problems in an efficient way. I'm going to explain you the important functionalities or the methods of DQ and how to use it. And there is also going to be a myth buster. There is a myth about DQ, and I think it is a very simple concept to understand, which many of you may have a wrong understanding on, and I'm going to clear that as well. So first of all, let's create a queue. And before we create a queue, let me tell you how to import this DQ. So this DQ is under the collections module of Python. So you can say from collections import DQ. And now let's create an object of DQ. So let us say DQ is equal to DEQUE. That's the DQ. And inside this, you can pass some elements as an iterable to give it some initial data, or you may skip this as well. So let us say we have some data, which is, let us say 4, 7, and 1. So I can pass this data here, and if I print the DQ, you will see that we have 3 elements. We have 4, 7, and 1. Let me open the console and let me run the code as of now. So Python space dq-1.py, that's my file. Hit enter, and you will see that we have created a DQ with 3 elements, 4, 7, and 1. Now, one of the methods of DQ is append. You can append any data into this. This should not be an iterable, or if you are expecting to just extend the the DQ with more elements from an iterable, so there is a separate method for it, that is extend. We are going to see this, but we are going to add any data into the queue, into the DQ. So let us say we have one more element. Let's say the element is equal to 10, and if I want to add this element into the data, and I want to add this element at the last, so I can say data dot append element. And now if I just print the DQ again, you will see that we have, okay, so it is not appended. That's fine. Let us see why it is not appended. We have done the append part. Data dot, okay, so we have done the data dot append. It should be DQ dot append, not data dot append. So DQ dot append the element. And if I clear the console, run the code again, you will see that we have 4, 7, and 1, the initial data, and then we have 10 as well, right? So that's the append for you. And this is done in O of 1 time complexity. Now, this append is used for inserting the element at the last. What about if you want to insert the element at the start? Then you will have to use another method called as dq.appendleft. Now, this is going to append the element at the leftmost part, or I would say at the start of your data. And let us say you want to append something like 15. All right. So now if you print the code, or if you run the code, you will see that 15 is at the start, and then you have your initial data 4, 7, and 1, and then you have 10, right? So these are our elements. So this is the append and append left method for you. All of these methods, both of these method is performed at constant time complexity, O of 1 time complexity. Now there is one more method called as clear, which is used to remove all the elements of your DQ. Now this is also done in O of 1 time complexity. I can say DQ.clear, and if you run this now, you will see that the queue is empty now because we have cleared all the elements. And this is also done in constant time. If you want to remove all the elements, it is done in constant time. Basically, the head, if you see, this is how a queue looks like, right? We have a head. Just this head is now pointing at none. The moment you say dq.clear, your head will point to none, and now all of these data will be garbage collected, and this operation is performed in O of 1 time complexity. Your all the elements are gone from the queue. So these are 3 methods. Let us see one more method called as count. If you want to perform the counting of a particular element in your data, let us say you have a data like 4, 7, 1, 1, 10. That's your initial data, and let's not clear the queue for now. And later on, we have added one more 10 to our queue, and we have appended 15 as well at the start. Now, if I want to count how many 10s are there in my queue, so I can say, let me print this, print dq.count, and I want to count how many 10s we have. So let me clear the console, run the code, and you will see that we have this as the queue. It has 2 number of 10s. That's the 2 here, right? So count is the method which can be used to count the elements in your queue, and this is performed in O of n time complexity because it will go through the entire elements of the queue, and then it will match whatever the element matches with your search element, that is 10. It will count that particular element, and then at the end it will return you the total count. The next is extend. Now this is very important to understand. Let us say you have like this is your queue right now. Okay, this is your queue which has around I would say 7 elements: 15, 4, 7, 1, 1, 10, 10. Now let us say you have a list. Let us say we have L equal to a list which has 3 elements, 1, 2, and 3. Now if I say dq.append L, and if I print this dq, then this 1, 2, 3 will not be added as an element in your queue. Rather, this whole list will be added as one element in your queue. If I run this, you can see that we have these elements, and then we have this 1, 2, 3 as an element. But what if I want that I have a iterable or I have a list and I want to extend my data, extend my queue with all the elements of the list. So instead of append, I can make use of extend. And now if I just clear the console, run the code again, you will see that we have the initial elements at 15, 4, 7, 1, 1, 10, 10. And then 1, 2, 3 of the list is now appended as an element in your data. So this is the extend method for you. And it is done in O of L time complexity, where L is the number of elements in your list. So extend is not constant. It depends upon the number of items in your iterable which you want to append. Similarly, there is something called as extend left. If you want to extend your elements, extend your list elements in the right side, then you can use extend. But what if I want this particular data 1, 2, 3 not at the last but at the start? So instead of extend, I can say extend left. Save this, clear the console, run the code, and you will see that we have 3, 2, 1 here, and we have the remaining list here, or the remaining queue here. The original queue was from 15 to 10. We have from 15 to 10, but 1, 2, 3 is added. One more important thing to understand here is your elements are getting added in reversed way. You might expect that 1 will be added first, then 2, then 3. No, first it will add this 1, all right, at the left, then it will add the 2 at the left, then it will be 3 at the left. So it will be 3, 2, 1. So if you want that the order of your list is preserved, add it when you are using the extend left method, add it in reversed format or reversed order. So I can say let's reverse this L. To reverse, I can simply use this particular shortcut, which is colon colon -1. And now this is a reversed list. If I run the code now, you will see that we have 1, 2, 3 added instead of 3, 2, 1, which was the earlier output. And then we have this original elements of the DQ. So this is the extend and extend left method for you. There is one more method called as reverse, which is used to reverse all the element of your list, not list, but DQ. So before I print this DQ, I can say DQ dot reverse. And if I just run the code, you will see that we have 10, 10, 1, 1, 7, 4, 15, then 3, 2, 1. Our original, our original DQ was 1, 2, 3, 15, 4, 7, 1, 1, 10, 10. So this got reversed. Now, what if I want to remove elements from my DQ? Then I will have to use methods called as pop and pop left. Both are done in O of 1 time complexity. The reverse was O of n, where n is the number of element in your queue, but pop and pop left will be done in constant time complexity. When I say pop, it is going to remove the elements from the last. When I say pop left, it is going to remove the element from the first. That is, it is going to remove the first element, pop left, it is going to remove the last element, that pop. So let's try this. If I say, let's print the DQ, and then if I say DQ dot pop, and if I print the DQ again, this should be DQ, not DP. So DQ, and then if I say DQ dot pop left, and if I print the DQ again, let us see what is the output and try to understand this. Clear the console, run the code again. Now this was your original queue before the pop happened. Now when you said pop, DQ dot pop, it removed the element from the last. So 1 is not here, right? And when I say pop left, it removed the element from the first. So we had two number of 10s. Now there is 1 10. One of the 10 is gone. The first one is gone. So these are the very important methods which you should know if you want to use the DQ data structure using Python. And it's not about Python. DQ is a very generic data structure, which is the doubly ended queue. Now these are all the important functionalities or the methods of DQ. Even if you are using some other programming language, these are the methods which you should focus on. How to add element at the start, how to add element at the end, how to count the elements, how to reverse the DQ, how to pop out the elements or remove the elements. Now let me ask you a very simple question. Let me first of all, let me print the console, like run the code and show you the logs in the console. Right now at the last, this is my DQ, right? It has around 1, 2, 3, 4, 5, 6, 7, 8 elements, right? If I want to access this particular data 7, let's do one thing. Let's print the length of this DQ, and you can use the standard Python way of printing the length. I can say print length of DQ, right? If I say print, now you can see that we have 8 elements. It means we have indexes from 0 to 7, right? Now if I want to access the index number 3, let us say we have this 0, 1, 2, 3. Let us say we want to access the element 7, which is at index number 3. So I can simply say print DQ, and then I can say 3, right? This should print 7. Now my question to you guys is, just tell me, if I'm saying DQ of 3, what is the time complexity of this particular process? Is it O of 1 or is it O of n? Let me put a hash here for a comment. So just tell me, is it O of 1 or is it O of n? Now that's the important myth which is there in the community. I would say it's not regarding the doubly ended queue, but it's how the Python implementation is done. It looks like a list, but it is not exactly a list. So a lot of people think that if you are doing this indexing, like if you're trying to fetch an element using the indexes, then it is taking O of 1 time complexity, which is a general time complexity if you want to access an element using the indexes, if you are using arrays or list. But if you are using doubly ended queue, this is not O of 1, this is O of n. So if you want to access a particular element at a particular index in your DQ, so it is not a constant time complexity, it is a linear time complexity. The number of elements in your queue will be your time complexity. Now the reason is your queue is implemented in something like this. So if you want to access an element at a particular index, it cannot just directly jump at that index. It will have to go through the head, right? Now if it goes through the head, then it is basically looping through, right? So the best way of using this DQ is in those areas or in those questions where you have to access the element only at the start or at the end. If you focus on the start and end element, if I say DQ of 0, then this is not going to take O of n time complexity. It is just going to take constant time complexity, which is O of 1. If I print this, you will see that it is 10. That's the first element. Or even if I want to access the last element, I can say DQ of -1, and I can access the last element as well, which is 2, the last one, and it is also constant time complexity. The first and last element are fine. So if you want to process on a list of data from the start or from the end, that is accessing the first or the last element, in those use case, do use the DQ, but do not try to use the DQ in place where you will have to access the elements randomly using indexes, because that is not going to help you a lot. So that was a small myth, and I think if you focus on doubly ended queue, that's not a myth. But if you focus on the way it is implemented in Python, then this myth gets generated, because people think that okay, in list also we can just access the element using a particular index. So you can, but not in DQ. So I think guys, that's it for this one. In this video we have seen I think everything regarding DQ which you should know if you want to use this in any questions or in any data structure and algorithm problems. So that's it for this one guys. If this video has helped you to understand about DQ, then make sure that you hit that like button and do subscribe to the channel if you have not done so. But if you have any questions, any feedback, then make sure that you use that comment box for this, and I will see you guys in the next video. I want to see you guys in the next one. Thank you for watching this one.